Hi guys, method second paper, multiple choice questions. This is VC Motivation Group Tutors sample answers. Um, I'll try to be descriptive as possible with these questions. Let's start with the question one. So, function that has a range of uh, 6 to 12. I probably will not use a calculator for this question. So, your range uh, is from 6 to 12. So we talk about this line. So in that case, the first solution that you have, here's the first solution is it is a cost value. So then your maximum should be 6 plus 3, which is 9, and your minimum should be 6 minus 3, which is 3. So that is not the correct and appropriate answer. Second one is 6 plus 6, 12, 6 minus 6, 0. That's not the correct answer either. Next one is 9 plus 3, 12, and 9 minus 3 is 6. Yes. So appropriate answer is answer C. Okay. The second one, all asymptotes of the graphs of this tan are given by, okay. I can think of two methods to do this question. Actually, I will use my calculator. Uh, this is a tan function. So tan is defined by, tan theta is defined by sine theta over cos theta. So if cos theta goes to 0, so entire function goes to infinity, which is an asymptote. Probably I will use that method to do the question. And also, let me think. I can use the domain function as well on the calculator. Okay, let's try both the methods. Okay, so the first method I'm going to do, uh, I get the solve function, solve cos, I'm having pi multiplied by x plus half, right? That has to be equal to 0, comma x, okay? Okay, x is equal to n1 means all integers. So then cos x will be 0 in all integers. In that case, your asymptotes, so then cos theta, so cos theta approaches 0 for all theta is equal to integer values, I should say k. So k is an integer. In that case, it looks like your answer is A. Let's try this using our second method, which is the domain function. With the domain function, should be domain of 2 n. So pi times x plus half. So domain of this function, okay, that means x should not be equal to an integer. Yep, answer is confirmed. That is the answer. It's A. Okay, the graph of y is equal to fx is shown below. Okay, which one of the following options best represents the reflection across the y-axis and vertical translation of 2 units? Okay, okay. So this graph, let me think, the shortest method. Probably I will draw this rather than doing any other methods. So your graph has um, a turning point here, a turning point there, and also turning point here. Probably what we can do is we can reflect this graph across the y-axis. If we do that, so this will become, it's hard to draw it as I was thinking. Actually, it should go up to here, I believe, right? It should be like this. And that will come over here. Then what happens is this graph goes up by positive 2. The entire graph goes up by positive. Okay, it looks like, so I can very clearly see that 3 here and 3 there. Okay, your answer is only one answer is more suitably. Yeah, that's answer B. Okay, next one. Okay, the next question is a simultaneous equation question. This is a system of equations. Okay. Find the values for this system has no real solutions. No real solutions in the sense you need to have these two lines. They should be parallel. Those two lines should be parallel. So in that case, your M1 and M2 should be equal to each other, but your C1 and C2 should not be equal to each other. So then it should be an and condition in between them. Okay, both of those conditions should occur simultaneously. Okay, um, I can use the solve function. That's one of the methods. Let me. So you can make y as your subject. Okay, the long method. You can do y is equal to negative k on 3 plus k squared on 3. In the second equation, y is equal to negative 2 over 2k plus 1 minus 2k over, so 2k plus 1. Okay, so your first condition, these two should be equal to each other. Okay, you should have x, such a mistakes here and x there. And the second condition, these two should not be equal to each other. Yeah, so k squared on 3, yeah, probably that's one of the methods. The second method you can think of, simply dividing your coefficients, right? So your first coefficient, which is k on k and 2, k on 2 should be equal to 3 over 2k plus 1, and k squared or k squared should not be equal to, sorry, k squared over the second coefficient, which is 2, should not be equal to, so k squared over, yeah, let me repeat it. I think it's wrong. Let me write it again. Okay, so this is method, this is the first method, method 1. My second method, my method 2, k on 2 is equal to 3 over 2k plus 1, and k over 2 should not be equal to k squared over 6 minus 2k. Okay, I'm just comparing those coefficients. Both the methods should give me the same answer actually. I'll try one of the methods, right? I'll go to menu, algebra solve. I have two equations, right? Um, Actually, these two equations, I have only one value, right? K. Um, okay, I have only one value. The first equation should be, let me do it properly. So that one is K on K on 2. Okay, K on 2 should be equal to 3 over 2K plus 1. 3 over 2K plus 1. Second equation, the same thing here. So, let me do it properly. Okay, so K over 2 should not be equal to K squared over 6 minus 2K, right? So 6 minus 2 times K. Is that right? Correct. Okay. Both the conditions are satisfied with K is equal to -2. Okay, do you have that answer? Yes, that's the answer. So answer is A. Okay. Which of the following sets represents functions that has an inverse function? Okay. The coordinates, inverse function in the sense you need to have, it has to be a function first, right? So it has to be a function which is the vertical line test, and it should be one-to-one to have the inverse function. So therefore, you need to check whether any of those coordinates are having common x or y coordinates. The first one actually, here I can see 2 and 2, it's common. So I believe it's x is y. So then it is. So x is here and y is there, right? For same x value of 2, you're having 2 y values. So this one is a one to many mapping. The second one, if you look at, it doesn't have any repetitions actually. So there are no repeated x coordinates and no repeated y coordinates. Therefore, that should be the appropriate answer, answer B. If you look at the third answer, just go through the process of elimination. If you look at the third answer, it has 3 in common here, right? So the third answer has 3 in common. Okay. So fourth answer has 1 in common. Yeah, you can reject everything. Your appropriate answer is answer B. Okay. Next question is a trapezium rule. Right? You can go to the formula sheet. The trapezium rule is used with two trapeziums to estimate the area bound by the graph of this. The x-axis, okay. Okay, you have to go to the theory part here. So if you go into your basic theory, so 3 minus e to the power of x, right? So e to the power of x graph actually minus e to the power of x graph, right? So that is minus e to the power of x graph actually. Looks like this. And you need to add 3 into it. So graph goes up. So your graph looks like this, I believe, right? You have an asymptote here. So if you simply get two trapeziums here to there, right? I will probably enlarge that portion. If I enlarge that portion, so you have a graph going in this way. What you're doing is you are having two slices. Your first slice is here, and this is your second slice. Okay. So estimation actually with trapezium method comes in this way, right? So your graph is above the trapezium's non-parallel side. So therefore, estimated area is smaller than the graph area, but they're asking estimate is larger than the exact area. Okay, this is one of the methods that you can do. The second method you can do actually is you can simply use the trapezium rule. So if you use a trapezium rule, so this goes from 0 to 1, and that is half. So you basically have your n is equal to 2. You have two slices. Then you can write this as 1 over 4, right? So f0 plus 2 times f half plus 1 times f1, right? You can do this for the actual graph, right? And your estimated value is here, your actual graph is an integral, right? I think that method is very complicated and it's a bit longer. You can do it, but you can do is you can say for the first equation, you can get integration goes from 0 to 1 fx dx, take away this number and check whether it's negative or positive. I'll probably do one question or two questions, um, two of those scenarios just to check whether which one is the correct method. So I can define fx here. Fx is equal to, I get the first one, which is 3 minus e to the power of x, 3 minus e to the power of x. This is my fx. Okay. And my trapezium, my integral answer comes from here. It goes from 0 to 1 fx, okay, dx. And I'm going to subtract, I'm going to subtract, right, 1/4 of f0 plus 2 times f half plus 1 times f of 1. Okay, if you get this answer, if it is a, okay, well, it's a very small answer. This actually gives me the integral value is greater than the estimate. Okay, let's repeat this with the second graph. Second graph is my fx is equal to x cubed plus 1. Okay, now let's repeat this. There's a negative value. This gives me the estimated area is larger than the actual integrated value. Okay, therefore, it should be the correct answer. Let's draw this. It's a cubic graph, right? It's a cubic graph. It goes up by 1. So it's a cubic graph. It goes up by 1. So basically, your graph looks like this, right? So then if you slice it into 2, correct, your trapezium estimate line goes above. Correct. So answer B is correct. Okay. Um, pseudocoding question. It's a very simple and very small piece of code. Let's have a look. In order the values are printed in the algorithm. Okay. Okay, the best way to do this question is I think you can check the while loop, right? So initially you have n and k values already assigned in the question. So let's do it. Your n is 17. Your n value initially is 17, is given, right? Is 17. Why? Your k value, I don't know it is changing, but I'll probably get that into the table as well, is 5. So then you're having your third one, which is n. And let's check what are you going to print here. Okay, so let's go through the while loop. If you come from the top, n is 17. Okay, those are the assignments. While n is greater than k, just check whether n is greater than k in the first iteration. Yes, it is greater. Then it will enter into the loop. Perfect. Good. So then your new assignment, n will be n minus k, which is, so 17 minus 5, which is 12. Okay. And print n, 12 will be printed. Okay. Satisfied. Then it goes back to the loop here. It checks whether n is greater than k. Correct. It is greater than k. It is true. And this will be executed again. Okay. Going through the path. So comes over here. So new value of n is 12. So then 12 minus k, which is 5. Right. So that is, sorry, 7 actually. 12 minus 5, sorry, the other way, 12 minus 5 is 7. So that will be printed as well. Correct. I'll I'll go back to the condition check. So when I go back to the condition check, so in the third round, your value of n is 7. 7 take away k, which is 5. Value is 2. So n will be 2. 2 will be printed. 1, 2, 3. Then it goes back to the loop. When I check the loop here, so now the value is 2 minus, no, it will not, because, no, it will not actually do it, because in that condition, it has to be n greater than k. But now my n is 2, which is less than 5, right? While loop gets stopped. So then only these three numbers will be printed. Your answer should be that. Okay, very simple question. Okay, it's not a hard question actually. Question 8. A random sample of n Victorian households, let's take an estimate proportion of the Victorian households, which is approximately 95%. Okay, if you say 95%, you can get this Z number. So from the formula sheet, your Z value is 1.96 here for 95% of the confidence interval, right? Which is 95%. So we know that value. Okay, what's happening here is your confidence interval is 0. Okay, your CI here is equal to 0.248 comma 0.552. Okay, this tells me my p hat, which is the sample proportion straight away, which is the mid value of this. I can add these two and add these two numbers and divide by 2, right? So that is 0.248, actually 552,248. That should be 800, right? That's 800 divided by 2 is 4, 0.4. So 0.800 divided by 2, which is 0.4. That should be my mid value. Okay, so if I draw that here, what happens is this is my confidence interval, this is my lower value, this is my upper value, and the p hat should be in between, right? So then this part is my margin of error. Okay, how do I find margin of error? Formula for margin of error is equal to Z value times square root. So you have to get your uh, p hat multiplied by 1 minus p hat divided by n. Okay, you plug those numbers in now. Margin of error is equal to, um, so I know the number here, right? That is margin of error, right? So because p hat value is 0.4. Yes, I know that. The top value here is 0.552. Therefore, 552 take away um, 400 is my margin of error. Okay, so 0.5 take away 0.552, right? 0.552 take away 0.4 is my margin of error, which is 0.152. Okay, so then I can get 0.152 is equal to 1.96 times, right? 0.4 multiplied by 0.6 divided by n, which is my unknown. Okay, I need to use my calculator here. All right. So I could have added that into the calculator in one, which is a solve function, right? So 0.152 is equal to, so 1.96, right? Yes. Let's what is the square root I have. 0.4 times 0.24 is 0.24 divided by, I should say, x. Yeah, this is the value, comma x. Okay, 39.90. 39.90 is approximately 40, correct. There's no other answer, right? Just 40 should be the answer. Okay, 40 is the answer. Okay. Uh, if I want to double check, I can go to statistics calculation. I can go to Z1 prop and get 40 as my samples and 4 as my 0.4 as my p hat value, and get the lower and upper confidence interval values. Okay, I probably leave that for you to check. Go to the next part. Okay. How students walk to school? Okay. It's a three-item question, a standard question actually. Travel to school, different transport method. Okay, you have two branches, right? The first branch is you're walking. That's your first branch. This is the walking branch. The second branch is you're not walking. What's the method? A different one, different transfer. Okay, D. Okay. Um, so M students walking, and in total should be M plus N students. So then this branch has to be M divided by M plus N, and the second branch has to be N divided by M plus N. Okay. If M students who walk to school took at least 30 minutes to get, at least 30 minutes means should be a larger number than 30 minutes, right? So this number at least 30 minutes, okay? So I probably will get so time is greater than or equals 30. The other branch is time is less than 30, okay? Here also, this branch, your time is greater than or equals 30. That branch, your time is just simply less than 30. Okay. Um, M students walk to school 20%. Okay, so then this one is the fraction here, right? I probably will use fractions as well. 0.2 is 10. So then I can use 1 on 5 here. That has to be 4 on 5. The second one is 40%, which is 2 on 5. There has to be 3 on 5, right? Okay. What's the question now? Question is, given that randomly selected student took at least 30 minutes to get into school. Okay. So it's a given that, which is a conditional probability question. Given that, so time is greater than or equals 30. What's the probability that they walk to school? Ah, okay, this is the question. Okay, probability that I probably shrink the top part, then I get more space to write. Okay, I'll leave it here. So then, so that means, okay, so your numerator is probability of walk intersection, time is greater than or equals 30 divided by the probability of time is greater than or equals 30. That's one. It's okay. So where do you get your denominator first? So where's the denominator? Denominator is your time is greater than or equals 30, which is this branch and that branch, those two branches addition. Probably can use a calculator if you want. Um, so so 1/5. So then I can write it. My denominator is uh, m over 5 times m plus n plus this guy is 3 on 5, right? Which is 3n over uh, 5 times m plus n. I think that's correct. Correct. So the top branch, you need to get the value, which is m over, yeah, this branch, right? That one, which is m over 5 times m plus n. Okay, looks like my denominators are canceling out, right? So this denominator, this one and the one, they are getting cancelled. Correct. So then here in the top, I am having m, and at the bottom, same denominator, which is m plus, it is 2, actually not 3, right? This is 2. This is 2, the one, right? 2. It's 2 actually. It's 2n, m plus 2n. So your answer should be m over m plus 2n. That should be the answer. That should be the answer. You can simplify this using the calculator as well, but it's easier to do using the manual method, right? Okay, it's my question 10. So there are two functions. The first function is a quadratic function, and the second function is a sine function. Okay. And you're supposed to find something of f of g of x, which is greater than 0. Okay, let's try to find the function. My g is sine x. Okay, so then f of g of x I can write. So f of g of x is equal to 2 times, so g of x squared plus g of x minus 1. That's the function. All right. You're supposed to get the positive value. If you get a quadratic function, right? If you need to find which is greater than 0, what I'm going to do, I will actually plot this, right? You can consider this as something like, so 2a squared plus a minus 1 is greater than 0. So, which is 2a and a, you have 1 and 1, cross multiply, 2a, a. So this is positive, this is negative, right? So your factors are 2a plus 1 and a plus 1. So this gives you two solutions. So let's try to plot it. All right. If I plot that function, it's a parabola. I should get a nice parabola actually. No, no, it doesn't work. Okay, don't worry about it. Okay, this is my parabola. So I have two answers. My first answer is one is negative, right? So that has to be it's a negative value, right? 2a minus 1. This is negative. So this is negative. Therefore, that is positive half, and this value is negative 1. So then your graph goes like this, right? Okay, good. So then this axis is your F circle G axis, whereas this axis is your G axis. Okay. Yes, correct. Correct. Those are the two axes that you're having. We know that domain of the original function here, this domain is everything, right? It's a quadratic function. Range actually goes from here to infinity, right? And in this question, g of x, right, which is my inner function here, right? G of x is my inner function. The inner function has its range of this function. It goes from -1 to +1, right? Therefore, beyond -1, this function will not exist. Therefore, I need to exclude this portion, right? I need to find whether which part is its positive. Therefore, its positive part should be from half to infinity, which is that part, right? The positive part. Um, it says just greater than, therefore, it cannot, not infinity actually, sorry. It should go to 1 only, right? It should go to 1 only, right? So then it cannot go beyond that. So then your answer should be C here, right? Your answer should be C. Those two brackets are very important here, actually, right? Let me correct it. So it should go up to here only. Okay, this value should be 1. Yeah, your answer should be C. The chart below shows the daily price of a stock. It's like a further question. Over which of the following time intervals? Okay, you're supposed to find the average rate of change, which is the gradient of the function, right? So first two, it should go from here, go from 3 to 10. 1, 2, 3, 3 to 10. 10 is here. That's the one. So you are supposed to find actually the x values and y values. So 34, 35, this is 2. This point is 34.8, right? Your coordinates are so 3 comma 34.8 to here it's 10 comma 36 1 2 36.4. Then you have to do actually rather than doing this calculation, we can use our straight lines and just do the inspection method. So 3 to 10. Second one goes from 3 to 17, right? 15, 16, 17, 17, 15, 15, 16, 17 is here. Okay, that gradient. So next two, I'll go to the next one. is 14 to 21. This is 14. This one is 21, right? So 14 to 21. I'll do it right. Goes here. Last one goes from 14 to 28. It's very high. So 20 is it 30, 29? This one, right? Okay. Looks like the green one is the answer. Okay. Inspection is the easiest method for this question. Otherwise, you can do so y2 minus y1 over x2 minus x1. It takes time. Okay. Very simply and very quickly do that using inspection method. Okay. Question number 12. The normal random variable x is known that x is greater than 200 is this number. Okay. So this is distribution is normally distributed. Right. I don't know the mu value. I don't know the sigma value. Okay. But I know something. I know that greater than 200 is less than 0.5. Therefore, therefore, if I draw my graph, distribution graph, it should look like this, right? So this is my mean value. It should be 0.325, right? 0.325, then 200 should be somewhere here, right? And that area should be 0.325. Okay. Second part says 180 to 200. Okay. Is more than half. So if this is 0.325, uh, 0.5, 0.5 take away 0.325 is 175. But this number is 0.5. So it should be less than half value. Therefore, it should be somewhere here. This number is 180. Okay. It says that the second colored area is 0.589. Okay, correct. I think that's correct. Okay, let's read the question now. The mean and okay, straightforward question. They're asking the mean and standard deviation, right? So I believe you can do this question using two simultaneous equations, right? Actually, you can add inverse normal function into the simultaneous equation if you want. Otherwise, you can solve them separately. How do you do it? The easiest method, right? Easiest method, you can convert them into um, Z values. That's the easiest method, right? So how do you convert them to Z value? So your your mm, first number, you can actually draw another line here, this line. Okay, this is your Z value, this is your X distribution. The corresponding Z value here you can calculate. Okay, so under this value is 180. 180 minus mu divided by sigma. The one is 200 minus mu divided by sigma, right? So corresponding area here, right, in the Z distribution graph. It's a bad graph, right? I should draw it right. This graph, right? So this area, now change to the area. Area is 0.325. You can find this area. How do you find this area? You need to add 0.589, 589, and 0.325, 0.325, all right? And then one takeaway, the answer that is 0.086, okay? That little area. a little area. So 0.086. It's a little area. Here, is it correct? 5, it's almost 600 and 900 should be 1. Yeah, I think so. I think. Okay. So let's get the inverse normal function. So it's not on my calculator. Okay. Doesn't move properly my calculator. Let's try to write it. It's easier. Okay. I'll write this. So I'm getting inverse norm, right? Okay, this value is 0.086, 0.086, and mean is 0, and standard deviation is 1. Okay, that one is that value here is negative, right? 1.365, whatever the number, right? I can find the second value as well. That has to be 1 minus 0.3. So this value should be 1 minus 0.325, 0.325, because your calculator doesn't work because it's a TI, it doesn't work from right. So I have to do it properly. Okay, this answer is 0.4537. Okay. Um, okay, then you can solve them simultaneously, which is 180 minus mu, I should say, A over B is equal to negative 1.365. And the second one is 200 minus A over B is equal to 0.0537. Okay. Or if you want to do this in one go, actually, you can use menu algebra solve system of simultaneous equations. I'll use A and B here. A comma B, two equations. Right? So this is the inverse normal value, and this is the second inverse normal value. Right? This should be equal to 180 minus A, 180 minus A divided by B. Right? Let me copy that. Can save some time here. So that one is 200 minus A. 200 minus A, right? I'm supposed to find A and B. These are the two values. The first one is 195. The second one is 10.99 is 11. So my answer should be 195 and 11. So E is 195, which is the mu value. Mu is 195 and sigma is 11. Okay, this is the answer. Took some time. Could have done easier. Okay. This question. Sketching the same. Okay. Easiest method for this question. This is a quotic function. Just get some numbers, right? Just get a typical graph for this function. So let's say this value is -1, this value is 0, this value is +1, this value is +2, right? So then your graph is g of x graph is equal to x times x plus 1 times x minus 1 times x minus 2, and your f of x graph is equal to negative x, probably negative x. Okay, that's it. Okay, just define those two functions in the calculator. Um, your first one, f of x, is equal to negative x, and your g of x is equal to x times x plus 1 times x minus 1 times x minus 2. I can get similar numbers, right? Okay, let's plot them first. Okay, just g of x. Yeah, pretty good. Just get f of x. Good. Okay, yes. Um, 4 here, like negative 4. The one has positive 4. Okay, yeah, looks good, I believe. Yeah, probably slightly different, but because of my scale, I believe. So this is 5, right? I make it 5 and 5. Negative 5. And this one is positive 5. Yeah, looks good. Okay. What do I need now? I want to get g of f of x, right? Let's plot it. So g of f of x. Okay. So black color graph, right? Definitely it is not A, it is not B, it is not D, it is C. It is C. This is C. Okay. Okay. Okay, so far so good. Um, it's a probability density function for continuous value of x. K is a positive real number. Okay, K is a positive real number here. It goes from 5 and 4. Okay, the value of K. So cannot get any other method because this is a probability density function. The area under the curve should be equal to 1. That's the only method I can think of actually, right? Yes. Okay, let's do, uh, is it correct? Let me think. Yeah, yeah. Just checking whether any tricky parts in the question. No, I think we can simply get those two integrations, not differentiation, two integrations. First one, it goes from 0 to pi on 4. It's uppercase, right? So pi on 4. And my function is k times sine of x, dx, right, plus my second function, copy that. Okay, please, yeah. It goes from uh, pi on 4 to pi on 2, right? So that function is k times cosine x, right? This area has to be equal to 1. So I'm solving this for k, solving this function. Okay, right. So right. That's the answer. K is equal to, I have an answer like that. No. I think this is the rationalized answer, the calculated answer is rationalized. Um, let's try to de-rationalize this. Okay, I have root 2 plus 2 over 2, multiply top and bottom both by the conjugate, which is root 2 minus 2 divided by root 2 minus 2. Let's try it. So top will be, right, 2 minus 4, bottom will be root 2 minus 2, right, which is negative 2 over root 2 minus 2. If I change the sign negative, which is 2 over, sorry, this 2 is cancelled out with this 2. I forgot. This is 2. Right? There's one more 2 is cancelled out. So then this 2 is not there anymore. So it's 1. So 2 minus root 2 is the answer. Answer B. Correct. I don't know why. It's not desocialized. Okay. Question 15. Where the graph of phi(x) passes through point 1, 3, the graph of this must pass through the point. Okay. So if I get the function which is y is equal to 1 minus g of take 2 out, which is x minus 3 of 2, right? Is that right? Correct. Okay. So, correct. Yeah. So this tells me, so dilation by half from the y-axis and translation in the positive direction, and reflection, the entire graph goes up in the end by 1, right? Okay, that's a translation. So I can think of, right, I have 1 here. So what happens to 1? So you have 1, and that will be reflected, that will be negative 1, that will become half, right? Then um, you have a negative 3 on 2, which will become, so negative 4 on 2, and that is negative 2, right? So it is, okay, no, we're talking about x actually, not negative. Reflection is not applicable here, right? So it's a negative value. Just go with the x. So x value, you have 1 here. 1 will become half, right? Is that correct? Yes. So, and you are getting 3 on 2 here. So, which is 4 on 2, which is 2. X value will be 2. You have two answers like this, right? And what will happen to the y value? Y value is 3. It gets reflected. That will become negative 3. It goes up by 1. Add 1, which is negative 2. So then your answer is that one. Your answer is B. The other method you can do, actually, I was thinking, you can consider this as a graph, right? Get a typical graph. Let me minimize this. We get a typical graph. So you have a parabola, right? So 1, 3 is your turning point, right? 1, comma 3 is your turning point. Don't worry about dilations here. Then your graph will be y is equal to x minus 1 squared plus 3. Correct? Yes. Then just do it. Just open up a new book here. So define my fx. Fx as, yeah, probably we'll do it in this way. X minus 1 squared plus 3. Correct. Okay, let's plot it. Control I. So this is your f of x graph. Correct. Let's do the second graph. Second graph is 1 minus f of not x, it's 2 times x minus 3, right? That's a graph. Okay. So this point is 1, 3. This point is 2, 2. Yeah. Okay. This is the turning point. If you want, you can find the turning point here using the maximum value. Analyze graph maximum. This graph, yeah, 2 minus 2. That's correct. That's the answer. Perfect. We go to the next one, 16. Okay. So consider the function of hx is equal to a log bx, a log e bx. Okay. Two things to know actually in this question. First one is, you know that every log graph should have the inner value is positive, right? So therefore, most important part here, so red color. So b times x value has to be positive, right? That number has to be a positive number. So graphs wise, if I get the derivative of this, so h dash x is equal to a over x, right? Let me think it again. Okay, a over x is a hyperbola, right? You said that your h dash of x function, which is your hyperbola, right? This hyperbola is defined, its range goes from 0 to infinity. So basically, it does not have this bit. It only has this portion of the graph. Okay, that's the first part of it. Okay. Now, look, I think the answers, let me go to check the answers. Answers have like a is greater than 0, a is greater than 0, b is okay. So then we have to consider all the combinations here. What are the combinations I can think of? The first one is a positive, b positive, right? Second scenario, a is positive, b is negative. Okay. Third scenario, a is negative, b is negative, b is positive. Last one, both are negative, right? So a is negative and b is negative. Okay. Think about the original graph actually. If a is positive and b is positive, your original graph is a standard log graph. If b is negative, your graph goes like this. Your x values are negative, right? Okay. If a is negative and b is positive, your graph goes like that. The last graph, they both are negative, right? In that case, your graph goes in this way. It's a log graph. Okay. Uh, so then if you think about your inverse graph should go from, its range goes from 0 to infinity. Okay. But we know that this has to be satisfied, right? This condition has to be satisfied because your inner value should always be a positive number. That's why when your graph goes into this direction, your x values are negative. Okay, your x values are negative here. Okay. Uh, therefore, therefore, if you want to satisfy this scenario here, it is satisfied with this condition, right? It is satisfied with this condition. Okay, it is satisfied with this condition. Okay, which is good. It is satisfied with this condition, which is good. And also, if both are negative, right, your your derivative graph goes into this shape. It is also satisfied. This is also true. Okay, good. But if you go into the middle scenario, what happens is your b value is your a value is positive, b value is negative, or the other way, right? Your derivative graph is not above. Yeah, that's the answer. So then they both have to be positive and positive. Okay, so both have to be positive and positive in the sense this one and that one. So both have to be. Oh no, both have to be positive. Either both have to be positive or both have to be negative. Okay, your answer should be the last one. Your answer should be D. This one, right? The multiplication has to be positive. That should be the answer. Okay, what's this one? Given that, um, okay, 1 to 2 is greater than 1 to 3. 1 to 2 is greater than 1 to 3. 1 to 2. Ah, because this talk about the net, not the net value. They talk about negative values as well here, right? Because you need to think about the area with negative sign. Okay, so if you think about here, this area is small, this area is small, right? It's negative, it's negatively small. And if you get the second part, this part is negatively large, right? So in that case, 1 to 2 is a negative small value is larger than the negative. I think that is the answer. A is the answer. Let's check the others. So if you go into here, 1 to 2 is a negatively large. No, that's wrong. Okay. The one, yeah, is correct. A is correct. Okay, this question. Consider the following graphs. Okay. Hmm. Okay, you are supposed to find the expected value, which is a mean, right? How do you find the expected value? Expected value is the addition of x times fx, right? So then you need to multiply your x value with the probability value, which is zero point 0.1. Ah, okay. So this number is 1 times 0.1, 0.1. This is 2 times 0.8, 3 times 1.2, 4 times 0.1, 0.4. This is 0. Add them together. Okay. Second one, the one is zero point 0.1, 2 times, which is 0.4, 3 times 0.9, 4 times 4, 0.16. This is 0. Okay. Just add them to, I'll use it. So calculator later. 1 times 4.5, right? 0.45. 2 times 2.5, 0.5. 3 times 1.5, 0.45. 4 times 1.5, 0.60. That one is same value. Should be the same value then, right? Because you're adding the same. So 1 times 0.2, 0.2, 0.2, 0.2, 0.2, 1, 2, 3, 4, 5. So if I, no, actually, no, I was wrong. Multiply this by the number, right? So 0.2 multiplied by 1, mm, which is zero point 0.2, 0.2, 0.4, 0.6, 0.8, 1.0. Add them together. 2, 6, 12, 20, 12, 8, 20, 40 is 20, or 2. I think this is 3. Add them together. 45, 90, 140, 200, which is 2, right? This is 3. Add that together. 1, 0 0.1. This is 2, 2.1, 2.5. The one more solution. 1, 5, 5%, 14, 20, 30. Yeah, these two answers are equal. So 2 and 4. 2 and 4. This is the answer. You probably can do this question using methods as a further method as well. You can add this into your calculator like a variable, like a spreadsheet, but takes time. This method is quicker. Okay. Let A be a point on the graph. I could see when the curve such that the line segment of okay. So in this question, you have a graph, right? Your graph is a log graph, right? Log graph x minus 1. So then x minus 1 means your log graph goes like this. Your log graph goes like that, right? You're supposed to find y equals x. Y equals x is that line, right? Y equals x line. What they said was c has multiple values. So c has different values. So then you will move this in this direction, right? If you think about this, what happens is the shortest distance always comes if I copy this here and draw a tangent to this line, tangent this curve, and shortest distance always occurs at the point of that touching point to the third line or second line, we call it uh, perpendicular distance. So let me explain that again actually. So you have to find the shortest distance, right? The shortest distance comes from the tangent point um, perpendicular drawn onto the third line. So this is the distance. Okay. What we have to do? Actually, I know the gradient here, right? This gradient is 1. This gradient is 1. Therefore, then I can easily find this x value, right? Can I? Yes. Yes. So what is the differentiation? Okay. I can do solve, right? I'll get the derivative of this function x, which is log x minus 1. The derivative should be equal to the derivative value, right? The derivative value should be equal to 1. I'm supposed to find the x. X is equal to 2. Perfect. At this point, x is equal to 2. Okay. Can I find the y value? It's 2 minus 1. Oh, actually, this comes onto the x-axis then. So it goes like this. So y value is 0. When I substitute here, so 2 minus 1 is 0, log e1 is 0. So basically this point is 2 comma 0 point. Right. Actually, we can sketch it. We can sketch it in the calculator. That's, I think, much easier than using the other method. Okay, let's get this bigger, a screen bigger. So let's add a new graphing sheet. So my first graph is equal to log x minus 1. This graph, yeah, this is the point. Okay, let's draw all these four functions now and check whether which one gives us the appropriate. I think that's quicker. My function should be x plus root 2 root 2, right, minus 2. Okay, that's my first line. Let's do the second one. That's my, oh, no, control is wrong. So I need to get that one above, right? Right here. It's easier. The second one, we'll copy this. So just root 2. Ah, it's above. Okay, get that one over here as well. Third one. Third one is x plus 1. It's there. Close it. Next line is just x. Okay, let's try to analyze this function. Probably a bit larger. 2. This is like negative 2. And this is 2. And this is negative 2. And make this grid into 1. That's much easier. It's into 1. Okay, great. All right. Now you're supposed to find the distance from here, right? The perpendicular distance, we get the graph here, to this line as root 2, right? So this distance is 1 and that distance is 1. So basically what I'm having is I'm having a grid here. In that grid, this is 1, this is 1. If you think about Pythagoras, right, square root of 1 plus 1 square root, this should be root 2. So it satisfies actually with the question, root 2. So distance has to be equal to root 2. Therefore, the appropriate graph here is the brown colored graph, this graph. Okay, let's find the, it is that one, right? So the F7 brown color graph. So which is just y equals x graph. So if I go into the answer now, y equals f graph answer. So there's something that's happened to my calculator. Let me minimize it. Okay. So my answer should be y equals x graph, right? So y is equal to x graph. X plus c is 0. So the new answer is 0. Good. Okay. Last question. Very good. Okay. The last question I have a to the power of x. Okay. Let's consider it then 1 x. Okay. Translations. So a to the power of x is the fx graph. The second one is a 2x plus 2. Okay. Which one of the following sequence transformations applied to fx does not produce gx? Basically, what you need is you need to apply your transformation here. Then your answer should be equal to g of x, right? Okay. Is that right? Very okay. Dilation factor of 2, half from the y-axis. If I do it half from the y-axis, this will be a to the power of 2x, right? Half from the y-axis, a to the power of 2x. Then the second one is translation by 1 unit in the negative direction of the x-axis. So Translation by 1. So then that means a negative direction means plus 1. Okay, so this is equal to e to the power of 2x plus 2. Correct. This is correct. Okay, I'm getting the appropriate one. Second one, dilation factor of half from the y-axis. Okay, which is similar to the first one, which is a to the power of 2 of x. Then dilation by effect of a squared from the x-axis, okay, multiplied by a squared. Then I can rewrite this as a to the power of 2x plus 2, which is equal to g of x. Correct. These two are correct. These two answers are correct. Perfect. Third one, dilation by a factor of a from the x-axis. So then a times a to the power of x. Okay. Then dilation by a factor of half from the y-axis. So then I have a here. So this is my graph, which is a to the power of 2 of x. Okay. Then translation 1 unit in the positive direction, which is negative 1, right? Positive is negative 1. This is negative 1 in here. Mm. Let's try to simplify this. So you're having a to the power of 2x minus 2. This 1 goes there, plus 1, which is a to the power of 2x minus 1. No, this is not equal to. So therefore, your answer has to be C. Right. You can actually check the last one as well. Dilation factor of a cubed from the x-axis, which is a cubed times a to the power of x times translation by 1 unit in the positive um, direction of the x-axis. Okay, positive direction of the x-axis. Okay, a dilation by effect of half in the y-axis. Okay, so then what? No, actually half, right? Yeah, it should be half for x only actually. Okay, so it should be like this, like that. So then a to the power of 3 times x, a to the power of x on 2 minus 1. So then your answer should be a to the power of, is that right? No, sorry, it's half. Mistake. Let's do it again. It's half. Let's do it again. My mistake. It's half. Should be a to the power of 3 times a to the power of x. Okay. Translation by 1 unit in the positive direction of the x-axis. Okay. Then half. Okay. So that means a to the power of 3 times a to the power of 2x minus 1. So which is equal to a to the power of 2x plus 2, which is equal to g. Yeah, as is correct. Okay, done. Thanks, guys.